All right, good morning, everybody out there in Zoom land. We are going to be getting started in 1 minute. So go ahead and grab a sheet of paper and follow along with me. We're going to be doing the 2014 SOL. And that is, yep, on your desk.
Yeah, I met him on the way up here. I mean, when I was going in there, I passed him. And
Yep.
I didn't think anything of it. And they told me when I got to him.
All right, so 2014 Algebra 2 SOL, we are doing 26 through 38. All right, let's look at number 26. So 26 says a solution to a quadratic equation is 13 minus 11i square root of 7. If this is true, which of the following must also be a solution? So let's go ahead and write that down. We got z equals what? 13 minus 11. And what I'm going to do is, since there's a square root of 7i, I'm going to put the square root of 7 right here and then put I at the end. Okay, so this is an imaginary number, and you can tell because we have the I. And remember that I is always going to be equal to the square root of -1. That's the way we're allowed to take square roots of negative numbers. You have to use imaginary numbers to do that. So if this is a solution, then the complex conjugate must also be a solution. The complex conjugate. So what is that going to look like? It's going to look like Z, same letter, but instead of just having a Z, it's going to have a bar over it. It'll look like this. And what's going to happen with this is the real part, which is not attached to the I, is 13. That's going to remain the same. So you're still going to have a positive 13, but the sign on the imaginary part is going to flip. So it used to be a negative 11 square root of 7. Now it's going to be a positive 11 square root of 7i. Or you could write it as 13 plus 11i square root of 7 if you put the square root at the end. So either one of these will work. All right, so looking up here, we can't use A or B because they're both negative 13s. So the only one that will work is D. Hey, how you doing there, Coach? You're not assisting with any SOL testing?
No, but I got to set up those private placements.
Oh,
I
okay.
got contact about 6 people, about 12 people I got to contact.
Yeah.
I just want to, I'll wait till you finish.
Okay. Well, you can come back at 9:45 if you want.
What's going on?
Something about a second and third block. They got the schedule all switched up this week. Okay.
I'll wait till you
All
finish.
right. 27. Which of the following functions does not have a range of real numbers greater than or equal to 0? So we're going to have a range. And remember that the range is the set of all y values. And we're looking for a range of real numbers greater than or equal to 0, So we're looking for this basically. Y has to be greater than or equal to 0. And then it gives us a bunch of functions. So let's look at A, square root of 4 minus x. So what we're going to do with these is we're going to graph them, and we're going to look at the range of each function. So I'm going to go to Desmos, and I'm going to type in square root of 4 minus x. When I look at all the y values are going to start at 0. That's the x-axis, and it's going to go up from there. So this one is going to have a range of y is greater than or equal to 0. Let's look at B. F of x equals the absolute value of x minus 4. So let's go ahead and graph that. F of x equals absolute value. I'm going to use the ABS. And when I do that, I get a V-shaped graph. Notice that the y values are going to start down here at 0, and then they're going to go upwards from there. So this is going to be y is greater than or equal to 0. All right, let's look at C. C says x to the 4th power. Let's see what that looks like. I'm going to type in x to the 4th power, and I get this U-shaped graph. So what is the range of this graph? The y values, they're going to start at 0 on the x-axis, and they're just going to go up from there. So y is greater than or equal to 0. Let's look at D now. What is this function going to be? Log x. Log x. So let's graph this one and see what it looks like. Log of x. What is the range of this function? Well, where do the y values start and where do they end? The y values are starting at -infinity if you go all the way down. And then where do they end up at? Well, if you follow this function, they're just going to keep on going up as you go to the right. So the range of this function is going to be all real numbers. All real numbers. So I think the question asks which one does not have a range of y is greater than or equal to 0. So it's going to be D, obviously. That's the only one where the range is different. Okay, let's look at 28. What is the sum of this infinite series? So we got 100, 60, 36. Plus, what was that last term? 108 over 5. And then ... All right, so for this one, we have an infinite series. Infinite series. And what that means is you're going to have an infinite number of terms. That's why we have ... at the end. The terms keep on going like that forever, which means we are adding up an infinite amount of numbers. So how can we do this? Well, first of all, you need to remember the infinite series formula, right? S infinity, that's an infinite sum. It's going to be equal to A1 divided by 1 minus R, where R cannot be equal to 1, right? So we need to figure out two things. We need to figure out what A1 is, and we need to figure out what R is. Once we got these two numbers, we can plug them into the formula and then figure out what the sum is going to be. So let's do that. First of all, what is A1? A1 is going to be the first term, right? That's going to be 100. That's the very first number that they give us. And then what is R? R is going to be the number that we multiply by to get from one term to the next. So what do we have to multiply 100 by to get to 60? And what do we have to multiply 60 by to get to 36? What do we have to multiply 36 by to get to this fraction, 108 over 5? Whatever we multiply by, and I'll put times R at the top of this, that's what our R is going to be. So R is going to be your common ratio. What are you multiplying 100 by to get to 60? So what I can do is I can take one of these numbers and divide by the number that comes before it. So let's see what we get when we do that. I can take 60 divided by 100. That's going to be 6 over 10. And I can simplify that down to 3 over 5. So does that make sense? 3 over 5. That's the number that we're multiplying by to get to each new number. So 100 times 3 over 5, which written as a decimal is going to be 0.6, if you want to think about it that way. It's the number that you're multiplying by each time. So I'm going to put a box around this. So now we know that R is going to be 3 over 5. Now we got both of the numbers that we can put into this formula. So let's go ahead and try it. We have S infinity is equal to a 1 at the top. That's going to be 100. And then in the denominator of the fraction, we've got 1 minus R. Well, what is R? That's going to be 3/5, right? So the 100 isn't going to change at the top, but the denominator will. What's 1 minus 3/5? That's going to be 2/5, right? So I'll put 2/5 at the bottom. And then if you're dividing by a fraction, that's the same thing as multiplying by the reciprocal. So you're actually multiplying by 5 over 2. And then if you multiply 100 by 5, you're going to get 500. You're dividing by 2 at the bottom. So 500 divided by 2 is 250. 250. That's going to be our answer. Okay. So for this one, you just needed to know first term and what your R value is. And once you find that, you can put it in the infinite series formula. Let's try 29. Okay, for 29, it says the graph of a parent function is shown, and it asks which function belongs to this same family. So what you'll see right here is you will see two U shapes. That's a hyperbola, right? The only graph that will match this in terms of parent functions is going to be the reciprocal function. The reciprocal function, right? So when we learned about parent functions, we learned that there was a function called the reciprocal function, and its formula is 1 over x. So what we're going to do is we're going to go back to each answer choice, and we're going to see if any of them are similar to this right here, 1 over x. And if they're similar, that means that they belong to the same function family. So which one best matches up with 1 over x? It can't be the logarithm. It can't be the 1/3 to the x minus 1 power. Can't be the 3 to the x minus 1 power either, since it's not exponential. So the only remaining choice is D. And D is going to be g of x is equal to 3 over x minus 1, I think. Yep, 3 over x minus 1. So when we graph this function, we should be able to get something that looks like two different U shapes. So let me go to Desmos and we will graph this. G of x is equal to 3 over x minus 1. And we get this black graph right here, and you can see the two U shapes. So that's very similar to what we have right here. That's why the answer is D. Okay, moving on down to 30. We have a log function. So let's go ahead and write that down. We have a logarithmic there we go. And what is it called? F of x equals log of 4x minus 1. And what we want to do is we want to find the zeros. Find the zeros. So what we're going to do is we're going to take this function and set it equal to 0. And now we need to figure out what x is. So one of the things to know about logarithms is the log of 1 is always equal to 0. Log of 1 is always equal to 0. So I need to figure out what value 4x minus 1 would have to be to make the inside equal to 1. So I'm going to take this out, set it equal to 1, and see what we get. So working with this equation right here, I could add 1 to both sides. That way I get 4x is equal to 1 plus 1, which is 2. And then from there, I can divide both sides by 4. When I do that, I get x equals 2 over 4. 2 over 4, right? And if I was to reduce that fraction down, I'll get 1 over 2. or 1/2. So just setting the inside equal to 1, I get x is equal to 1/2. And this comes from the rule that if you take the logarithm of 1, you're always going to get 0, no matter what your base of logarithm is. So if they don't tell you what the base is, you automatically assume it to be what? 10. That's right. That's called the common logarithm. Now, another thing that we can do to find zeros is we can graph it, right? So let's do that. So my function was f of x equals log of 4x minus 1, I think. And I get this red graph right here. Well, what is a 0? It's also where the graph crosses the x-axis. So where does this graph cross the x-axis? Right here at 0.5. What is 0.5? I could type that in right here. And if I change it to a fraction by clicking this button, I get 1/2. So that's another way you can check your answer. And you know that your x value has to be 1/2 for this to work. So what was that? 30. So the answer is C, 1/2. Okay, let's look at 31. So 31 says, what is the horizontal asymptote of this equation? Let's write it down first. I've got f of x is equal to 6. F of x is equal to 6. To the x 5 power minus 4 at the end. And I'm looking for a horizontal asymptote. So a horizontal asymptote is always going to have the equation y equals c, where c is some number. So let's go ahead and graph this and see where the asymptote is. So 6 is going to be our base, and we're raising it to the x minus 5 power. I'm going to put this in parentheses so it doesn't mess up on me. And then the last thing that I'm going to do is I'm going to subtract 4 down below the exponent so it doesn't get confused up here with the exponent. And I'm looking for a horizontal asymptote. So where is the horizontal line that the graph doesn't cross? It's going to be basically this line right here, right? And what y value is it at? -1, -2, -3, -4, right? Y equals -4. So that's that green line down there. But I'm going to change it to a blue dotted line so you can see it a little bit better. So now what you'll notice is this graph actually never crosses this blue dotted line. So I could zoom in as far as I want to. This graph is never going to cross this dotted line. And if it looks like it does, it may be your eyes playing tricks on you. So you might want to zoom in and actually see what it's doing. So that's pretty cool. So y equals -4. Now, is that an answer choice? It might be. Yep, it's C. Y equals -4. Okay, moving right along, let's do 32. Which function best represents this graph? They give you this exponential function. And notice that it has a horizontal asymptote at -4. So you know that you're going to have a -4 being subtracted off to the side. So you know it's going to be D. F of x is equal to 2 to the x power minus 4. I think. Was that the right function? Yes. So the answer is going to be D for 32. That one's pretty easy. And if you want to check it, you could just graph it on Desmos. All right, moving right along to 33. They give us a function, g of x is equal to log of 2x. And it's basically asking, does it have an x-intercept? If it does, how many does it have? If it has a y-intercept, how many does it have? So we're going to be looking at that today. So g of x is equal to log of 2x. And we want to ask the question, does it have x-intercepts? Does it have y-intercepts? So let's graph this and figure it out. So I need to graph the logarithm of 2x. And I can't see it. That's probably because I'm zoomed in too far. I'm going to hit the home button over here. There we go. So does this graph has an x-intercept? Yes, right here. That's where it crosses the x-axis. So we know that it has one x-intercept at x equals 1/2 or 0.5. Does it cross the y-axis? Well, going back to our graph, it looks like it does, right? But does it really cross the y-axis? We can zoom in and see that it really doesn't. And even if you think it is crossing the y-axis, you could just zoom in and then see that it never really crosses. So this function is going to have a vertical asymptote on the y-axis. That's why it crosses. So for y-intercepts, we're going to say none. None whatsoever. Okay, so we know it has one x-intercept, no y-intercepts. Which answer choice best represents this? It's going to be B. One x-intercept, no y-intercepts. So I'm going to put a B down here. Okay, let's look at 34. It says, throughout which of the following intervals is f of x only decreasing? So it gives us a function, f of x is equal to x minus 1. They tell us to put it in parentheses. And then x minus 4, the quantity squared. And it asks for intervals of decreasing. So I'm going to write decreasing. Where is the function decreasing? Well, the first thing we can do is graph it. So I'm going to go to Desmos and I'm going to graph this function. We have x minus 1 times x minus 4 squared. And my function looks like this. It's kind of got a cubic shape to it because the highest exponent for this graph is going to be a 3. So we know we have an x cubed somewhere in here. But the question isn't asking that. It's asking, where is it decreasing? Decreasing means the function goes down. Where is the function going down? Well, as we move in from the left side, it's going up. It's going up, 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 until you reach the top of this hill, right? Then it starts going down. It goes down, 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 until you reach the bottom of the hill, which is this point, conveniently. And then the function starts going up again. It starts increasing again. So where is the function decreasing? From this point to this point. What are the x values associated with those points? We got 2 to 4. So that's where the function is decreasing, between 2 and 4. So I can say when x is between 2 and 4, like that, the function is going down. It's decreasing, right? So is there an answer choice for this? Yep, it's going to be D. X is between 2 and 4. So you can write it this way with a little line underneath. This means less than or equal to. Or you can write it like this. You can write it as equals 16. Now, another way you can figure this out is you can take the entire expression inside the parentheses right here and set it equal to 0. So you could do x minus 16 is equal to 0. You can solve this by adding 16 to both sides, and it equals 16. The same thing that we got from the graph. So that's going to be A. All right, let's look at 36. So 36 says the graph of a function is shown on the grid. What appears to be the range of the function? So if you remember that range means y values, it's basically asking what y values does this graph take up? And what I'm going to do is I'm going to zoom in on it so you can see it a little bit better. Maybe a little bit more. Okay, I think that's good. So looking at this function, which y values does it take up? Well, it looks like it starts right here. And it's starting at the y value of 1 right here. Notice that the y-axis says 1. And then it appears at 2.